Hello everyone, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So today I'm going to solve some of the problems from classical mechanics. So today's topic is generating functions. So before we start, inhale confidence and exhale doubt. So you're going to do it only when you inhale confidence. So before generating function, these are some of the properties of Poisson bracket that I left in my last video, and please make a note of these. And also, this is the condition for canonical transformation. This one is very important. That is, whenever you take Poisson bracket of two quantities, and if the answer is one, we say that the quantities are canonically transformed. So this is an important formula to know. And now let us go to our main topic, generating functions. So generating functions, what are these generating functions? So whenever an old coordinate is transformed to a new coordinate, then it is because of some function reacting on the old coordinate. So that function which reacts on the old coordinate to give a new coordinate are generating functions. So there are four generating functions, and you have to remember these four generating functions and their dependencies. That is, if f1 is dependent on q1 and capital qi. So similarly, you have to remember all these functions on which our generating function depends. So and if we see, both Lagrangian and Hamiltonian remains the same even after the transformation. And also the new Lagrangian changes only if our generating function is dependent on time. So let us solve theoretically, like how to get the relation between the generating function p and q and all those. So now from our last equation, we have df by dt is equal to L prime minus L, where L prime is the new Lagrangian and L is the old Lagrangian. So we are substituting that over here, and then on simplifying you get this first equation. And now let me take my first generating function, which depends on small q, capital Q, and t. So now I take the total derivative of this function, and on simplification you get this equation 2. So you can compare both equation 2 and 1, and after comparison you get the relation between our generating function, the old coordinate, new coordinate, and everything. So this is a theoretically based uh, steps where you can find the formulas for your generating function, old coordinate, new coordinate. But let me tell you a shortcut from where you can remember all these formulae very easily. So you have to learn this cloud. That is, dou f by dou present is equal to missing. If you remember this, everything is going to be very much easy. So we have this four generating function, and I have written that f1 is dependent on q, small q, capital Q. And what is this missing over here? Present is nothing but the dependencies. That is, small q and capital Q is the present terms. And what is missing? Small p and capital P is missing. Small p and capital P is missing. So now I will substitute in this formula. So missing is small p, which is equal to dou f by dou present. Now what should I take, small q or capital Q? Since this is small p, I'm going to take my small q. So every time just remember that if you're doing by this method, you'll have to take only the old coordinate. That is, if your old coordinate is p, then equate it with your old coordinate. And if your new coordinate is p, then equate it with your new coordinate. So there should not be any kind of confusion what to put instead of like small q or capital Q or small p or capital Q, capital P. So wherever you use small, you have to use uh, small in the left hand side too. Wherever you use capital P or capital Q on your left hand side, you'll have to use the same in your right hand side. So I hope this is easy for you to understand. And now next step is to see where to put this minus sign. So we have to check where which term should have minus and which term should have plus, right? So just remember this step, which says that QI, PI, that is small QI, small PI, capital QI, and capital PI. So remember this sequence, and then I'm just substituting negative sign for the first and the last term. So wherever you find small qi, you are going to put a negative sign, and wherever you find capital Pi, you are going to put the negative sign. So remember this sequence and remember where to put the negative sign. So now if you see here, the first generating function pi is equal to minus dou f1 by dou qi. Why is it minus? Because I have taken here pi to be negative, so it's negative over here. Similarly, here is qi, then it should be having a negative term. So here is a negative sign, and similarly over here we have a negative sign. Similarly, you can remember this formula. You have to just remember this one. You have to remember the functions that is on which they depend, and the sequence. Only if you remember these three steps, you're going to get all the relations. So I hope you understand this. Now let us go to a problem which says a canonical transformation relates the old coordinates of the new ones by the relation q is equal to q square and p is equal to p by 2q. The corresponding time independent generating function is. So we have the canonical transformation, that is it has been transformed from small q to capital Q, uh, and small q to capital Q, and then the corresponding time dependent generating function. So we have to find the generating function f. So how do you find this? Here q and p are being transformed. Q is transformed to capital Q and small p is transformed to capital P, and the relation is given over here, which is q is equal to q square and p is equal to p by 2q. When I just analyze this given information, I can find that my uh, f2 is the generating function, because you have q, and you have relation between q and capital Q, and you have relation between small p and capital P, and here f2 depends on small q, capital P and t. You have all those. That is, you can relate and solve this question only when you assume that your generating function is f2. Now what is present over here? Small q and capital P is present, and what is missing? Capital Q and small p is missing. So using that formula, I'm going to just substitute this. Q is equal to dou f2 by dou p. There is no negative sign here. We don't need that. And small p is equal to dou f2 by dou q. Now, in this first equation, that is q is equal to dou f2 by dou p, we have f2 is equal to, yeah. How do you find f2? We can just directly integrate, right? So I integrate q dp. So what is my q? It is q square. So on integration, I get q square p plus c. Similarly, I have p is equal to dou f2 by dou q. And how do I find my f2? I can just integrate with respect to dq. So I'm integrating p dq. Now, using this relation, I can find what is p, which is 2qp, capital P. So on simplifying that, I get the same q square p plus c. So on integration, you get the same answers. Hence, your generating function will be q square p. So I hope you understand this. So this is your homework problem. And the solution for my last problem was, like, the question was from Poisson brackets. So I have given C1, C2 and all those. One will just do a mistake here by using cyclic terms. See, because C1, C2 gives C3, and then C2, C3 will give C1, and then C3, C1 should give C2. So one will choose option C. Sorry, it's not option A. One will choose option A, but option A is not the right answer. You have to solve this with the following steps. So let us go to the solution. Answer is option D. So let us find the solution over here. So here C1 is x2 p3 plus x3 p2, and I have written all those C1, C2, C3, and then I'm going to find what is C2, C3, Poisson brackets of C2, C3. So I'm just substituting my C2 and C3 and simplifying those in different terms. So after simplification, this is the given data, that is same x1 p1 same indices are equal to 1, and different indices will be 0. So I'm not explaining this fully. You have to try this on your own. So Poisson brackets of C2, C3 is P2, X3 and into X1, P1. Just okay. You're going to simplify this, and you're going to get an answer which is similar to C1. So after simplifying this, you're going to get C2, C3, which is C1. And similarly, when you do C3, C1 and simplify, you're going to get minus C2. So just see my video and see the following steps. You'll get the solution. And if you're finding it very much hard, let me know. Comment me. I'll help you out. So uh, keep watching my videos, and I'll be uploading more videos soon. So thank you. Like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell. So see you later. Ta-da!